Hello, everyone. This is lecture 77 of Principles of Electric Circuits. We discuss LC resonance. Why do we discuss LC resonance? We've discussed in lecture 73 and 74 that small resistance in RLC serial resistance and small conductance in GCL parallel resistance are very common when we want to take advantage of resonance. In this condition, the circuit is transformed into LC resonant circuit. So the discussion on LC resonance helps us to understand the essence of the circuit more precisely. Firstly, let's discuss LC serial resonance. Obviously, the input impedance is a reactance since there's no resistance in the circuit. So Jx equals J omega L minus 1 over omega C. According to the definition of the resonance, the imaginary part of the impedance or the admittance is zero, so the resonant angular frequency is this. The input impedance of the port in resonance is zero. In other words, the port is short-circuited. For LC resonant circuit, we can easily draw the frequency characteristic of port reactance to analyze the circuit qualitatively. You see, the port reactance of LC serial resonance is like this. When omega tends to be zero, this part plays a leading role. It's a characteristic of a capacitor. The curve is like this, a negative reciprocal curve. When omega tends to be infinite, this part plays a leading role. This is a characteristic of an inductor, so this part plays a leading role. The sum of the two curves, when omega from 0 to infinite, is the frequency characteristic of the port reactance. This intersection is omega 0. You should be familiar with the frequency characteristic of port reactance of LC serial resistance. We need to point out when omega equals omega 0, the port reactance is 0, and the port represents the characteristic of the short circuit. Next, let's discuss LC parallel resonance. Because of a parallel connection, we can easily get its port susceptance like this. By the concept of duality, we know susceptance and reactance are dual concepts, and capacitance and inductance are dual too. From the expression of the port susceptance, we can easily draw its frequency characteristic. It's like this. This intersection is the same as that in the previous page, but we focus more on the frequency characteristic of port reactance. So for the frequency characteristic of port susceptance, we have two steps to go. Firstly, we put a minus sign before B. In other words, put the red curve upside down. This intersection is the resonant angular frequency omega 0. This function is negative B. Secondly, we calculate the reciprocal of the function. When omega tends to be 0, x tends to be 0. When omega tends to be omega 0 from a small value, x tends to be positive infinite. When omega tends to be infinite, x tends to be 0. And when omega tends to be omega 0 from large value, x tends to be negative infinite. So the frequency characteristic of the port reactance of LC parallel resonance is like this. You should remember this curve. When omega equals omega 0, the port reactance is infinite, so the port is open-circuited.